if you go after that chapter to the appendices, you're also going to find fun things like a pizza recipe and my favorite burger recipe. I still can't believe that they actually let me print that.
So let's dive into the book's contents. Now, obviously, in this particular kind of talk, we're not going to be able to do the sort of the whole book justice. It's kind of really a summary walkthrough of all the sections. But I thought it was kind of interesting to do that. And if obviously viewers want to learn more, they can actually go out and buy the book. So that's the that's kind of really the idea. But yeah, let's kind of you've I think kind of split it into three parts. So the first part of it is kind of chaos engineering fundamentals. So just kind of describe some of the sort of chapters in that particular part of the book, please.
Sure thing. So the intro chapters are there to basically trick you into doing some chaos engineering before you learn what chaos engineering is, and then convince you that it was a good idea. So it covers some nomenclature, things like blast radius, which is kind of intuitive. This is the amount of stuff that can be affected by your experiment. It covers also a template for doing an experiment.
Right.
So it's kind of like a four-step, marketing loved it, four-step to chaos engineering, because like I mentioned, the chaos experiments are basically like the unit of chaos engineering that you can do. So if you have a template, all of a sudden it sounds easy, but it's really not rocket science, any of that. It's basically step one is ensuring observability, another term that we define there. I'll give you some tools, which is basically making sure that you have a reliable way of measuring a variable, a metric, something that you care about. It could be anything from server works or server is up to I get a response within this time frame. Then step two is to define a steady state, which is just a fancy way of saying a normal range for that particular variable that you care about. Then you go step number three, and you create a hypothesis. You say, okay, so if something happens, my variable shouldn't be affected. Let's say that you have redundant system, and you say, okay, if I switch off one of those computers, I plug it off the wall, then I should still get responses within that time range, right?
Right.
And then number four is basically you go implement it and you see. And the nice thing is that, everybody gets a medal. If you were wrong, that's great, because that means that you learned something about your system and you found a way to improve it. And if it worked, well, pat yourself on the back. That means that you were actually right about your assumptions. So this is basically, to give you all the kind of things without going too deep, but give you examples of how you can start doing chaos engineering with like 3 lines of bash.
Right. Okay, cool. And yeah, so I mean, certainly all those terms, kind of blast radius, steady state, observability. But there's also, you mentioned a buzzword called understandability as well. Can you kind of explain what's happening with that and what's that kind of mean in these circles?
Well, I don't remember putting it in the book, but I heard the cool kids now talking about understandability, because observability is so last year. Now, understandability, the way I understand it is that you can have all the metrics in the world, but if they don't give you a clear image of what's actually important to look at, and it doesn't help you understand the problem, it's not really that useful. So I heard multiple definitions of understandability, and I suspect this is a buzzword we're going to keep here for a while. But this is kind of how I understand it so far.
Yeah, I'm sure we will. Okay, so yeah, the intro to kind of the book talks about, I think you mentioned emergent properties and behaviors, and you're kind of pitting this against sort of testing, which is more quote unquote, sort of under a specific set of conditions. Can you explain that a little bit more?
Yeah, so this is kind of what I touched upon, is that, like when you think about unit tests, they're depending on how well they're written, obviously, and how much of checkboxing exercises you want to have, 100% coverage kind of thing. You're really focusing on a very particular, you're probably testing a function or something of similar scope. And then, as you go up in the kind of blast radius, I guess, the scope of what you're testing, if you go up to the integration test and then you test probably components as a whole. And then with chaos engineering, it's important that you kind of test a system the way that it runs in the wild. So you test it as a whole, and that's when you can observe those different and weird behaviors. And that's where a lot of the kind of operational running stuff actually kicks in, because you can have a thing that has perfect unit test coverage, and then turns out that it's actually using too much, or it's starved from CPU by something else,
Right.
or doesn't have enough disk, or the disk is too slow, or you're trying to run I don't know, etcd or something like that on a network-based local storage, right? And then all of the operational elements play a massive role and are typically a little bit left behind by compared to actually ensuring that unit tests pass. So with chaos engineering, you kind of focus on all of those things, all of the variables that go into a system running okay or not okay, and you play with them and you see what happens.
Right. Okay. Okay. So let's move on to part 2 of the book and kind of some of the chapters. That one is called Chaos Engineering in Action. So you've focused on Docker, I believe, in that particular part. Can you expand a little bit more about sort of that sort of discussion around Docker?
Yeah. So part 2 is basically when I try to cover as much of different stacks that are popular right now.
Right.
So we do touch on Docker. There is a big chapter that basically tries to give you enough information about Docker and how it's actually implemented. Well, I keep saying Docker, but what I really mean is Linux containers.
Right.
More things like containerd that use namespaces and C groups under the hood. So we go into all the Linux kernel capabilities and functionalities that are used to implement the containers, so that you actually understand, where the magic stops and what the limitations are. And then we cover testing software that runs in containers and some tools that you can use. Other chapters, basically each chapter is kind of self-contained and tries to deal with some kind of popular problem. Like there's a chapter on what happens if you add latency to your database and how it actually affects the app. There's a chapter on JVM where we look into how you can, without modifying of the source code, how you can inject code and modify the code on the fly when it's being loaded into the JVM. So that you can work with this massive, very enterprise-ready application with thousands and thousands of dependencies, and just modify a little bit to inject some exception or something like that, and see what happens. That all the cascade of error handling is actually working nicely. And some other things, including the opposite approach of actually going and implementing some of the chaos engineering directly into the application code. And that's useful. For example, if you don't have any control over the platform you run on, you just have control over your little application. And also because it's very easy to do, and there are ways to do it in a non-invasive way to actually only activate that code or even load that code if you're running an experiment, right? And make it totally isolated, totally, what am I looking for? oh Jesus, inactive when you're not using it.
Right.
So this is kind of like a tour of different things and stacks and technologies that might be useful. Yeah, all
Okay.
the way to like doing UIs and JavaScript in the browser, because
Sure.
hey, why not? You can do casing with that too.
Right. Absolutely. And yes, I think, I mean, certainly the kind of, more focus on practice than theory certainly comes out in that particular part, and hence why you've called it, chaos engineering in action. But also, I mean, we were talking about kind of just that section, before the recording, and the uh, sort of you've put in, you kind of tried to cover lots of domains based on your sort of um, experience in terms of the sort of the experiments there, but also around, I think you kind of talked about sort of more modern tools in that space, in the chaos engineering space, and how you can kind of make use of those tools. And also, I think building around sort of experiments into application code directly. And I wanted to kind of ask you about that, because the sort of the impression I've had overall is that certain aspects that used to be in code are now kind of, the preference seems to be to kind of actually have them outside of the code. So we've had, with the advent of things like API gateways and things like the open policy agent, and a number of sort of components that used to be embedded in code have now actually been detached, from the code, and they're kind of running as a separate component. So the applications and the developers don't actually have to, be concerned with all those kind of components. So why is kind of the, in chaos engineering, why is kind of the drive seems to be, or the kind of the recommendation seems to be to actually include it into the code?
Oh no, that's not a recommendation. That's basically
Oh,
just
okay.
a way of me trying to cover all the cases, because I was trying to put myself in the shoes of different people. I
Okay.
obviously have a bias. I've been running platforms as a service for a while.
Right.
And so, I routinely look at other people's services running. But if you only have control over that one little service, there's nothing stopping you from doing case engineering on that. So it's not so much a recommendation, it's more of a kind of way of making sure that you understand that you can apply that methodology and kind of mindset regardless of what you do. It's not just for Netflix and Googles of the world. If you have a single application or even a legacy server, there's a there's a fun chapter where we're actually looking at what you can do to a legacy server that you don't even look at the code of. You just know from the tribal knowledge someone compiled it 10 years ago and still runs, it's still in use. And if you want to check how the error handling actually works when things are not going well, we go and go all the way down to the kernel level, and we start blocking some syscalls and see what happens. See how the actual error handling code is behaving in this kind of condition. So really, like the primary message here is that you don't need to be running massive distributed systems at Netflix scale to get value out of that. You can start small, and in fact, it's probably best to start small. And in any kind of circumstances, ranging from legacy single server running on a single machine, all the way to a massive system on Kubernetes.
Sure. Okay. So obviously, okay. So there's kind of a variety of sort of methods
Approaches, yeah.
yeah, people can actually kind of make use of. It doesn't have to be necessarily embedded. It doesn't have to be kind of a massive system. You can, as you said, you can kind of start small and then sort of build up your sort of portfolio of sort of chaos engineering tools and methodologies in that way. Excellent. And yeah, and obviously that part of the book kind of covers some of those basics that you can kind of go through and put those into practice. Okay,
Exactly.
so yeah, uh, kind of just moving on to part three. This is kind of where you kind of do a little bit more focus on Kubernetes and having sort of chaos engineering in the sort of the Kubernetes space. Why did you kind of want to specifically focus on Kubernetes? Was it again kind of from your experience, or was it kind of just a general good area to discuss?
Yeah, so you know how people say that software is eating the world, right? So Kubernetes ate the basically the container runtime world and ate it very quickly. That happened within, on my watch within a few years. So Kubernetes is basically now the de facto API for kind of container-based deployments. And even if tomorrow someone invents something twice better, I suspect that just the amount of money that has been invested in this by different companies means that we're probably going to be seeing that for the next decade or two, for the better or the worse. So, like, honestly, I've never seen like an open source project raise so quickly. So that's like the primary reason that even if you don't know about it, you might be running Kubernetes at some point in your daily routine. And the second is that a lot of, basically a lot of the resources that you have around us, they focus a lot on running the applications on Kubernetes rather than running Kubernetes itself. So I wanted to cover it from both perspectives of people who are responsible for running Kubernetes. And even if you're not, it's interesting to know how it works. So there's an entire chapter under the hood that basically goes into different components and the moving parts of how that thing is built, how it works, and how you can interact with it and kind of poke holes here and there to ensure that the way that you're running it is reliable. And then there's the other kind of hat of someone who runs software on Kubernetes, which is a very nice thing for chaos experimenting because you basically have an API that you can work with, and you can use that API to do anything from cloning things, modifying them, modifying routing, all the way to automatically getting logs from these things to verify that things worked. So it gives you a lot of room for automating things and making for better demos and, and nicer experiments. So yeah, I basically could not have not covered Kubernetes and go with a straight face and promote the book.
Absolutely, yeah. I think, as you said, it's quite pervasive, and yes, it is eating the world, isn't it? In those terms. You also there's a chapter which I liked as well, which was chaos engineering for people. I thought that was always you're always coming back to the human factor, aren't we? Sort of when it comes to these sort of systems and platforms. And what's the coverage? What's the coverage on that? What are you kind of talking about there?
Sure. So I think that might be one of my favorite chapters, and basically all of the credit for that goes to a certain individual called Dave Rensin, one of the original SRE gang, from the SRE book at Google, who's now onto a new venture, Plug. Who basically gave this presentation that really blew my mind a few years ago about how we can apply all of the same principles to human distributed systems that are also colloquially called teams. And when you think about it, we are all bio-robots executing distributed algorithms to kind of synchronize and deliver things that we get money for, that we can exchange for goods and services later on. And there are all kinds of things that happen exactly the same way in a distributed system as when it's made computers, or when it's made of human beings. So things like finding bottlenecks, things like introducing failure and seeing how reliable the retry logic is. All of that is just like an entire new way of looking at it, and I loved it so much that I really had to ask him to include that into the book. So he goes into describing these different games that you can play, and the games range from basically telling one person to become a bottleneck by not sharing relevant information, or all the way to like making a false alert so that people start panicking and try to solve an issue that never actually existed, and seeing how long it takes them to do that, or just slow down the communication. So this is like really, really, really mind-boggling to me that I only thought about that when Dave gave his presentation. So for everybody who goes through the book, I suspect that they'll probably go and jump to that chapter early on because it's really nice. Yeah. And for everybody else who didn't expect things, if you go after that chapter to the appendices, you're also going to find fun things like a pizza recipe and my favorite burger recipe. I still can't believe that they actually let me print that.
Brilliant. Well, Miko, thank you very much for taking the time to go through all the sections and parts of your book. Really appreciate that. It's been a really interesting talk. Now, as just for kind of viewers, if they're interested in kind of looking further details, we said we can't really do the book justice in this particular talk, but if people actually want to go and have a look at all the details of the book and actually buy the book, it's available from Amazon and also the publishers, which are manning.com, I believe. Is that correct?
That's correct.
Excellent. Okay, so I'll provide all this detail in the description of the video, so people can actually just go and have a look at all the links that I will put there. We also have a small competition where one lucky viewer can actually get an ebook copy of Miko's book as well. So one lucky viewer stands to win an ebook copy. And all they have to do is answer this particular question. Miko?
The question is, what's the name of the original software from Netflix that featured a primate and did chaos engineering?
Excellent. And just a big clue that we actually mentioned this earlier in the talk. So big clue for you in the actual video itself. Now, just a couple of things on the actual competition, how to enter that. Please send the answer on an email to the Cloud Therapist email address, which is thecloudtherapists@gmail.com. Again, I will pin that address in the comments section of the video, and it's also, I think, in the About section of the video channel, the YouTube channel itself as well. The competition itself will be open until, let's say, the 31st of August, 2021. So if you're watching this after that particular date, I'm afraid the competition is closed. And if you're watching this prior to that date, please get in for a chance to actually win an ebook copy of Miko's book, which is absolutely fantastic. It's a really great read. You're interested in chaos engineering and actually just learning about what is chaos engineering and generally sort of chaos engineering and sort of experimenting with tests and things like that. Furthermore, there's also more details in the description of the video on Miko's book and how you can actually get a discount from the publishers Manning at manning.com. They've actually kindly provided a permanent discount, I believe. I maybe want to get shot down for this, but I believe it's a permanent discount on all of their books, including obviously Miko's book itself. So again, I'll provide details of that in the video description. So go and have a look at that and have a look at all the kind of things that they're actually doing and they've made available on their website at manning.com. So I'll include all details in the description there and can have a look at that. So it only leaves me to thank Miko for coming on. Really appreciate your time. It's been a great talk. Again, as always, I've learned so much. And yeah, I wish you much continued success.
Thanks so much. Thanks a lot for having me on the show.
Thank you for watching this talk. If you enjoyed the content, please comment, share, like, and subscribe. See you next time.